Hello friends, I welcome you all in this session. As you are aware, in previous session we were discussing about ANOVA or analysis of variance. We have seen that we can use ANOVA for comparing means of two groups or more than two groups. Now let us say if there are four groups, we can solve the four groups example using t-test or z-test as well, but we will have to go for let us say 6 combinations or 6 pairs. 4C2 would be the number of pairs you would be forming. So when you have got 4 pairs, then every time there would be type 1 error in all those 4 pairs. So when you solve a question having 4 groups by let us say t-test, then the error probability would be very high. So to minimize that error, a new term or new tool has come, and that new tool or the technique is called analysis of variance or ANOVA. So if we use ANOVA, we will minimize the type 1 error. We did work out couple of examples in previous session. Today we will see some more examples. So let us look at this example. In a machine shop, there are 4 operators who are drilling on aluminum plate, and they have to drill a hole of let us say a diameter 6.25 mm plus minus 0.25 mm, right. So there are 4 operators in machine shop. So when the operator 1 makes hole or when he drills the aluminum plate, the diameter of hole is 6.33, 6.26, 6.31 and finally 6.41. So there are 1, 2, 3, 4, 5 holes made by operator 1 on aluminum plate. Similarly, operator 2, first hole diameter 6.26 and 6.22 is the diameter of the last hole. Similarly, third operator, these are the diameters of holes. Similarly, fourth operator. Now the question is, can we say that the mean of all these holes is same, or does the diameter or the mean of the hole depend upon type of operator? That is the question. So you would be framing null and alternative hypothesis, and we have to test that hypothesis at 0.05 significance level. So first of all, we will have to frame null and alternative hypothesis, and what we have said in null and alternative hypothesis in case of ANOVA, we will say that mu1 is equal to mu2 is equal to mu3 is equal to mu4, right. So these are mean diameters, they all are equal, that is our null hypothesis H naught. Alternative hypothesis would be at least one of them is not equal to others, right. So all means are not same or not same. This is our alternative hypothesis. Now when we say, let us for example, if mu3 is not equal to mu4, then we will reject null hypothesis, or let us say mu3 is equal to mu4, but let us say mu1 and mu2 are not equal, then also we will reject null hypothesis. So to solve this question, we will first of all find out sum of square among columns and sum of square within columns, right. So for that we need to have this process. So this is nothing but sum of square among columns, sum of square, this is within, right, and this is total sum of square. In other words, this is error term or unexplained term, this is explained term, and this is total variance. So, if you proceed in this question, we have got 5 units in first sample. So, 1, 2, 3, 4, 5, right, 8 holes in second sample or second group or second column, then 7 and 4, right. So, in this way we have got total 24 samples. So, first of all what you should do, you should find out the mean of each of these samples, each of these columns, and then grand mean, right. So, that can be calculated, right. So, once you are done with mean and grand mean, calculate column sum of squares are among column sum of square. It is one and the same thing, either you say SSA or SSC, right. Then when you apply this particular formula to all these values, we will get SSC as 0.23658. Now, you can easily calculate SSC for this question, that would be 0.15, right. Now, once we have got these two, then you need to calculate F value, which is the ratio of among column variance to within column variance, right. So, that F calculated value would be 10.18. Now, this 10.18 F calculated, but you will have to find out critical value from F table as well. So, for that you need to have you need to look at F table at 3 degrees of numerator, 3 degrees of freedom at numerator and 20 denominator, right. So, this is why this is 3, because you have got 4 groups, right. So, number of groups minus 1, C minus 1, right, this is 3, n minus C, n is nothing but number of items in each of those groups, right. So, this is 20. So, you need to look at that F critical value from table, and this is a partial table, F table at alpha is equal to 0.05, right. So, that value is 3.10. So, 3 degrees of numerator and 20 degrees of denominator. Let us see what is that value. These are numerator degrees of freedom, these are numerator and these are denominator, right. So, 3 and 20. So, this is this 3.10. So, this is your critical value F 3.10, and as we know that in ANOVA the F test is always a left tail test or lower tail test. So, this is our calculated F value, which is 10.18, which falls in rejection region. So, we will reject null hypothesis. We will reject null hypothesis, it means that all means are not same. There is a significant difference in the mean of, let us say, drilling example we have taken rather than calling it a valve opening example. So, we will say that the mean diameter produced by these 4 operators, they are not same, they are different, right. So, we'll work out the same example using Minitab software. So, this is the data we have got, right. So, we will do data entry now. So, first of all you can write here M1, M2, M3 and M4. Okay. So, for first we can look at data from this table. So, we got 6.33, 6.26, 6.33, 6.26, and then in next cell we have got 6.31. So, these data we have got in a separate paper. So, that is how we are doing entry. So, in first column there are only 5 units or 5 samples, right. 6.23, then 6.27, 6.19, 6.50. In fact, there are 8 samples or 8 units in this sample. 6.44. So, this is how you should do data entry in all these 4 columns. 6.56, 6.34, 6.58. You have got 7 samples in column 3. Then you have got 6.29, 6.23, 6.19, 6.21. After that, go to stat first, then ANOVA, one-way ANOVA. Now, here you have got, there are 2 ways of doing data entry. The first is response data in one column for all factor levels, or you can go for response data or in a separate column for each factor level, right. So, these are 4 columns. So, we will select all these 4 values and will choose responses over here, right. Then we will go to option. So, confidence level is 95%. However, this would be a lower tiltage, right. Then we will click OK, again click OK. So, let us look at, we just minimize this, yeah. So, we will look at p value in this, yeah. So, this is our ANOVA table, right, this is our ANOVA table, right. Now, if you look at ANOVA table, we have got calculated f value, which is this, right, it is 10.18, which is exactly similar to what we have got here, right. Yeah, this is the one, right. 10.18 is calculated f statistics, which is here, isn't it, right. Now, if you look at p value is 0, right. So, what is our definition of rejecting or non rejection of null hypothesis? We have always said that if p is less than alpha, will reject null hypothesis. In this case, p is equal to 0, alpha is 0.05. Is p less than alpha? Yes, p is less than alpha. So, we will reject null hypothesis and we will conclude that the means are not same, they are different. Let us look at one more example on one-way ANOVA. So, you want to see if 3 different golf clubs yield different distances. You randomly select 5 measurements from trials on an automated driving machine for each club at 0.05 significance level. Is there any significant difference in mean distance? So, these are the data points you have been given. So, for club 1, the first is 254, last is 251. For club 2, 234, 216, club 3, 200, 204. Now, here in all these 3 groups, you have got equal number of samples, right. So, what would be the null hypothesis and what would be alternative hypothesis? So, H naught is equal to what? That all these distances are same, right. So, mu 1, mu 2 and mu 3 are same, right, and they are not same is alternative hypothesis. So, these are different data points in this chart. So, for first group you got 254 and the lowest is let us say 250, 241, right. So, this is and these are your data points for first group, then for second and for third, right. So, first of all calculate mean of each of these groups and then grand mean, which is 227, right. So, this is nothing but 227, right, and x1 bar, x2 bar, x3 bar, these are these values, right, approximately 250, then this is 226, right, and this is 205, right. So, total n is 50, C means number of groups 3. So, among group sum of square is 4716 and similarly within sum of square our error term is this 1119.6. So, F statistics is 25.27. So, we have to look at now, we have to look at the F critical value, right. So, this is your rejection region. So, F critical value would be at what degrees of freedom of numerator? So, it is C minus 1, right. So, 2 degrees of freedom of numerator and 15 minus 3, right. These are 3 is nothing but C number of groups, 15 total number of points in each of these groups, right. So, this is 2 degrees of freedom numerator and 12 degrees of freedom of denominator, right, denominator. So, let us look at the table value 2 and 12. So, that value is there in next slide. So, 2 and 12. So, this is 3.89. So, 3.89 is this, right. This is the critical table value. Compare it with calculated F value which is in rejection region. So, we will reject null hypothesis, and null hypothesis is that all these mean distances are same. No, they are not same, we are rejecting it, right. In fact, if you look at in all these questions which we have worked out in ANOVA, we have rejected null hypothesis so far in all these examples. So, we have always said that the means are not same, but we do not know which two means are not same. So, that is a disadvantage of ANOVA. It does not tell us which two group means are not same. ANOVA tells only whether there is a significant difference amongst means or not, and then there are different methods available to check which two means are, which three means are, which four means are not same, or which different means are different from each others, right. So, conclusion is there is evidence that at least one mean differs from the rest of the means, okay. So, in fact, this is the table we have used. This is our if you solve this question using let us say Minitab or Excel, then you should get this answer. So, this is the average of first group, second, third, at the calculated F value is 25.27. Let us see whether it was there or not. So, we will wait for, we'll solve this question little later using Minitab. But so, this is our calculated F statistics 25.27, and the output from Excel is same, right, and F critical is 3.89. This is table value, that is what we have seen. P value, it would be, it is approximately 0, right. So, it is 4.99 to the power 10 to the power minus 5, right. So, you will also get, let us say, this within group and between group variance. Let's check again. So, within group variance 1119 and 4716, 1119 and 4716, and this was total 5836. This is the output from Minitab. You will get the same answer, right. P is almost 0, F is 25.28. It is not almost 0, it is 0, right. So, these are other values, right. So, you will also get this, the mean and standard deviation of all these groups. So, individual 95% confidence interval for mean based on pooled standard deviation, right, for all these 3 groups, right, and this pooled standard deviation. So, let us solve this question using Minitab. This is the question, and now let us go for data entry. So, we will have Minitab software now. So, there are now 3 groups, right. So, we can write club 1, club 2, club 3, or let us say C1, C2, C3. We can delete the remaining values over here. These are the values of previous question. So, the first one is, let us look at, so 254, 263, 254, 263, 241, 237, 251. So, these are 5 points for group 1, then for group 2, 235, 227, 216, 200, 222, 197, 206, 204, right. So, this is how you should do data entry. Let us look at, first we are deleting the output of previous question. So, we will go to stat ANOVA, one way ANOVA, right. So, you can click, yeah. So, you just delete this, we can right, select all these 3, select option, we'll check at what significance level we have to test it. So, we need to test this hypothesis at 0.05, right, it means 95. So, this is correct, this lower bound, we will press OK, again click OK, right. So, let us look at ANOVA table, which is there up, yeah, this is our ANOVA table, right. So, you just see this table is exactly similar to what I just showed. Let me show it once again. This is the ANOVA table and our answer is this, right. So, this is, you have got total, sum of total square, error and error variance and explained variance, right. So, this is P is 0, F value is 25.28. So, we will reject null hypothesis because P is less than alpha. So, we will reject null hypothesis, right. Now, let us look at one more question. Now, this is the question on the difference in average workers. So we have got a company has got 3 manufacturing plants. So the company officials want to determine whether there is a significant difference in average age of the workers of those 3 locations where plants are there, right. So the following data are the ages of 5 randomly selected workers at each plant. So we have selected total 15 workers and we noted down their age. Perform a one-way ANOVA to determine whether there is a significant difference in mean ages of the workers at 3 plants. Given alpha is equal to 0.01 and note that the sample sizes are equal, right. So what we will do, step 1 it's mu1, mu2, mu3, right. So this is, in fact you can write it like this, mu1, mu2, mu3, right. At least one of the means is different from others, right. Calculate F value, find out table value at 0.01 significance level. Now this is somewhat different from remaining questions we have solved on ANOVA. Here alpha is 0.01, in our earlier cases it was 0.05. So here you will have a different table, different F table for alpha is equal to 0.01. So we will look at that table and that value at 2 degrees of freedom numerator and 13 and 12, right, 12 degrees of freedom denominator, right. Why 12? This 15 minus number of groups, this is number of groups minus 1, right. So it is 6.93 and we will reject the null hypothesis if calculated F value is more than this, right. So this is how you can solve this question. So you have got, let us say, average age of first worker in first plant, age of fifth worker in first plant and so on, right. So you can calculate mean of these 3 groups, right. Then grand mean, again this is sum of square among columns, this is within sum of square within columns, this total sum of square. So the calculated F value is this, it is 39.8 and the table value is 6.93. So there is a significant difference in the mean ages of workers at these 3 plants, right. So this is the table when alpha is equal to 0.01. So we have to look at F critical value at 2 degrees of freedom numerator, right, this column, and 12 degrees of freedom at denominator, right. So this is the one, 6.93 is this, right. So this is how you can solve a question like this again using Minitab. So we will solve this question again quickly. So we will delete all this data related to previous question. So let us say these are 3 ages, let us say for plant 1, 2, 3. So it is 29, 27, 30, 27, 28. So these 5 points, next 5 points, these are different again ages for workers of plant 2, this is 25, 26, right. So we will go to, okay, first we will delete this, let us look at output. So stat one way ANOVA, So select all these three and then go to option. Here it is 99%, right? Click OK, OK, OK. So look at ANOVA table, so which is here, right? So this what is our calculated value, F value is 39.71 and P value is 0. So P is less than 0, so we will reject null hypothesis. So this is how you can work out examples on ANOVA using Minitab. Let me stop here for the time being. In next class we will see some more points related to ANOVA. Thank you.